The geometric series is a well-behaved series that we can pretty much analyze easily. One thing I want you to point out is, first of all, we start sum n equals 0 to infinity of a r to the n, which is going to be a r to the 0, which is just 1, plus a r to the first, plus a r squared, plus, as long as a doesn't equal 0, otherwise it's kind of trivial. Let's look at convergence and divergence. The sum, as n goes to infinity of a r to the n, clearly it diverges if the absolute value of r is greater than 1 or equal to 1. But what if the absolute value of r is less than 1? Then it converges, and its sum is a divided by 1 minus r. Again, note this starts at n equals 0. Let me show you the proof, because you may need to use this sort of trick later. Let me look at the nth partial sum. This is a plus ar plus ar squared plus ar to the n minus 1 plus ar to the n. And yes, you could have just factored the whole a out. Now, the next thing I'm going to do is multiply this by r. So r Sn is, now I'm going to move this over just a little bit, ar plus ar squared plus dot dot dot. Now what will this term right here be? This term will be ar to the n plus, oh, I should have moved over a little more, ar to the n plus 1. Now, you can see where this is going. Now I'm going to subtract these two equations. So S sub n minus r Sn is what? Well, these terms are going to cancel, and I'm left with a plus, those middle ones cancel. So it's a minus a r to the n. Now, let's do a little bit of factoring ourselves. Let me factor this Sn out. So Sn times 1 minus r is equal to, now I'm going to subtract out this a, so this is 1 minus r, oh, I forgot the plus 1, sorry about that, n plus 1. All right, so Sn then is a divided by 1 minus r. Now these don't have anything to do with n, times 1 minus r to the n plus 1. Now, if I look at the limit as n approaches infinity of Sn, it's going to be the limit as n approaches infinity of a divided by 1 minus r times 1 minus r to the n plus 1. Now remember, r is less than 1. All right, if r is less than 1, then this goes to 0. And so the sum, n goes from 0 to infinity of a r to the n, is just going to be a divided by 1 minus r. Now obviously if r is greater than 1, this diverges and the whole thing diverges. So let's just use this. Sometimes it's easier to just use this. Let's look at this series right here. This is 3 times the sum as n goes from 0 to infinity of 1/2 to the n. In this case, r is 1/2. So we know that the sum as n goes from 0 to infinity of 3 over 2 to the n is going to be, now I could have used a's, I chose not to. It's just going to be 3 times 1, because in this example my a is 1, a 1 minus r, and r is 1/2. So what does this become? 3 times 1 over 1/2, or 6. Let's look at this one right here. Obviously, in this case, r is 3/2, which is greater than 1, so this diverges. We're done. Now, sometimes we're going to use a repeating geometric series to look at repeating decimals. In order to do that, what I want to do is rewrite my repeating decimal, 0.080808 as 8 divided by 10 squared plus 8 divided by 10 to the 4th plus 8 divided by 10 to the 6th plus etc. So basically, we're going to rewrite this repeating decimal as the sum as n goes from 0 to infinity. When I do this, let's see, let me factor out, let me back up just a little bit. Let me rewrite this. Let me show you how to do this first. Okay, so this is 8 divided by 10 squared, all right? So what am I left with? I'm left with 1 plus, that goes away, 1 over 10 squared plus 1 over 10 to the 4th plus. Okay, so this is equal to the sum as n goes from 0 to infinity of 8 divided by 10 squared, hint, that's going to be my a, times what? 1 over 10 squared to the nth power. So when n is 0, this is 1. Okay, yes, that checks out. So in this case, I have a is 8 divided by 100, or 8 over 10 squared. I don't care which method you use. And r is 1 over 10 squared, or 1 over 100. Again, I don't care which one you use. So 0.08 is equal to what? It's going to equal a divided by 1 minus r, which is 8 divided by 100 divided by 1 minus 1 over 100, which is going to give you, if I get a common denominator, 8 divided by 100 divided by 99 divided by 100, or 8 divided by 99.